Hello, classmates. Welcome back. My name is Cytlaly Rodriguez, and let's get started. Okay, today we're going to be talking about Module 1, Chapter 1, Critical Thinking. So I want to start off with a mathematical question. Do you know why the mathematical tree fell over? Because it had no real roots. Let's start with problem number 1, solving the puzzle. Here we have a puzzle that goes horizontal and vertically. The goal is that the numbers horizontally and vertically need to add up to 31. Either way we go, horizontal or vertically, they need to add up to 31. In the first circle on the left, we are given the number 10. On the right, we are given the number 13. If we look vertically, we have the number 11. And in the middle, we have the number 8. The last number is 12. Using the guess and check method, I will place the smallest number in the center of the circle, which is A. First, let's look horizontally. If we add up 10, 8, and 13, we look vertically, we have the numbers 13. If we look vertically, we have number 11. After we use the guessing method, we add 10 and 8 and 13, which add up to 31. If we look vertically, we have 11, 8, and 12, which also add up to 31. Both methods, horizontally and vertically, add up to 31. I can play with different ways by switching the numbers up to see if they add up to 31. The answer is no other possibilities that will add up to 31. Let's look at the next puzzle. We are asked to complete the puzzle. Let's take a look at the puzzle above. In the upper left corner, we are given the number 7. If we subtract 7 from 15, because we are trying to get the number, what number plus 7 gives us 15, we have to do the opposite, which is subtract. So if we subtract 7 from 15, we get a total of 8. Therefore, the top right circle will be 8. Now, if we look at the right column vertically to get the number 20, we would subtract 8 from 20 and get a total of 12. The empty circle at the bottom would give us 12. If we look at the bottom left circle, we subtract 7 from 12 and get a total of 5. This is how the method works out how to figure out the missing numbers. As you can see, the numbers 7, 15, 20, and 17 and 12 are the numbers that were already given to us. So it was a little bit easier. We either knew we had to subtract or add and to figure it out. Let's look at this puzzle and complete it as well. Here we have to complete the puzzle once again. We are given the number 6 in the green right corner. We are also given the number 13, 21, 19, and 11. Since we have the number 6, we can start from there. So what plus or minus gets us 21? The number would be 15. Now, what plus or minus gives us 19? The answer is 4. What plus 4 or minus gives us 11? The answer is 7. Now we can see that the puzzle is completed. So it's the same method. We're doing plus or minus to figure out the numbers that are in the middle, to figure out the numbers that are missing in the circle by using the numbers in the middle or the numbers that were already given to us, which are in the green in this instance. Here we have to complete the puzzle once again. We are given the numbers 3, which is placed in the blue circle at the right, the purple circle in the blue circle at the bottom right corner. Next, we are given the number 15, 8, 6, and 12. Now let's begin with the number 3 since it's it was a number already given to us. So what plus 3 gives us a total of 6? The correct answer is 3. Now what plus 3 gives us a total of 12? The answer is 9. Now what 9 plus or minus gives us 15? The answer is 6. And that's how you complete this puzzle. Let's go ahead and get started with this. Here we are asked to find the missing number in the green circles. We are given the number 7, 16, 18, and 9. And the number 8 on the left bottom green circle. So we have a 9 in the middle. And so we ask ourselves, what plus or minus gives us 9? We can see that if we add 9 plus 1, we get 8 plus 1 gives us 9. So the answer to the top green circle is 1. Now, 1 plus or minus, what 1 plus or minus gives us 7? The answer is 6. Now, what 6 plus or minus gives us 16? The answer is 10. Now, 10 and 8 plus 8 would give us 18, which is how we get the number 18 at the bottom, which was already given to us, but this was just a reinsurance. Here, we have a figure 1 and figure 2. We will determine which figures have the least perimeter and the greatest by counting the sides. These two figures above, we are asked to figure out the perimeter of both of them. Each side is equal to 1, making the perimeter of the figure 1 equal to 18 units. And you might ask how or where did that answer come from? It is because we can see in the red on the right side we have 6 blocks. So from the top right side to the bottom goes up 1, 2, 3, 4, 5, 6. Then we have 6 plus 2, 2 plus 2 plus 1, which is the same thing as this in the red. 6 plus 2 plus 1 plus 1 plus 2 plus 1 plus 2 plus 1 plus 1 plus 1 gives us a total of 18 units. Then we have the one on figure 2. The perimeter of figure 2 is 16. How do we know this? Because if we look at 3 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 3 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 gives us a total of 16 units for the perimeter. Since we already found out the perimeter of each figure, we can see that the figure has one great perimeter. Figure 1 has a greater perimeter than figure 2. Although they do have 9 squares, the distance around each is different. So it does matter. The distance does matter. Here we ask, what does the next shape look like? We are given the picture on our left with a pattern of triangles that have been provided for us. Then we are asked to recreate 2 images, the one next to each other, that go to the next sequence. So we follow the sequence of the triangle pattern that we are provided on the left to see how many dots they continue to add. As we can see, the next pattern looks like this, like number 1, with 7 squares added to it. This is how the next shape will look like after adding 6 green dots. So number 1, adding 6 green dots. The pattern after this one will look like this on the right, with a pattern of 9 extra dots. Here we're asked to find the number to the sequence. What is the 10th term to the sequence 28? If we look closely, we notice from 1 it jumped to 4 and then 7. We can see that we're adding 3 each time to the pattern. In this instance, the sequence in the orange, we can see that after 7, we add 3 to get the next number, and then we add and get the total. So from 1 to 4, it's 3, and from 4 to 7, they're adding 3. But once we add all those numbers, we get the total results. So our formula is 3n minus 2. After we have this formula, it's easy for us to find the answer to whatever number. We continue to do that through the pattern, and we are asked to find the 10th term. This is easy because all we have to do is do plug and check or answer. So we look above and we can see for the 10th term, we replace the 10 for n. So we do 3 times 10, which is 30, minus 2, which gives us which gives us 28, which the 10th term is 28. Here we're asked to solve an equation in the unknown variables. Here we're given a pyramid and asked to solve the missing squares. As we can see, we have to solve for the missing numbers in the red with the x, the two squares that are gray in the x, and 7, which would be written x plus 7. Since we already know that the values of the other side of the squares, we add them together. It would look like this. X plus 7 plus 7 plus 3 equals 25. Next, we would combine like terms, leaving us with x plus 7 plus 10, because we're combining like terms, which gives us 25. Subtract 7 from 10 and get x plus 17, which is 25. Then we solve for x. X plus 17 equals 25. We subtract 7 from each side, 17 from each side, giving us a total of x equaling 8. To find the first square of the red one, we would have to add 8 and 7, which gives us 15, which is above on the green on the left side. And we add 7 and 3 in the middle, which gives us 10, which is the square right beside 15. To check our work, we would add up 15 and 10 all together and get a total of 25. And that's how we know that the number in the yellow at the top square is correct and that our numbers are correct. Let's look at 4b. Solving an equation for the unknown variables as well. We have another one. Here we have to solve just like the previous puzzle. The first step we have to do is 1 plus y, because we're given y, so pretend the 6 is not there yet, plus y plus 2. This is our bottom row. Step 2, we have to add like terms and solve for 1 plus y plus 2 equals 25. 2y plus 3 plus 15 minus 3, which gives us 2y divided by 12. And so by 2 and x equals 6. Now that we know that y equals 6, we can plug to solve the rest like this. 6 plus 1 equals 7, which gives us the first yellow square on the left. 6 plus 2 equals 8, which gives us the second yellow square on the right. If we add 7 and 8, we get a total of 15, which is the top green circle. And that's how we know that the answers are correct. That's we use, again, the guess and check method. So it works. Here we're given, we have to continue to determine the missing squares in the bottom dark green circle. Because the bottom circle square is missing, we subtract 2 from z. Now that the next step to find z on the right side, we would have to take the bottom 2 squares and add them to get the middle square. Z minus 2 plus 9 and z plus 7. We add the 2 middle squares to solve for z. Z plus 7 equals 27. 2z plus 7 equals 27. Subtract 7 from both sides and get 2z equals 20. We divide by 2 and get z equaling 10. So that's how we know that one. Plug and check. Here, in 5a, we are asked we have 4 married couples that belong to a bridge club. Sort them out in order to see who married who. Above, we are given a chart of boys and girls' name that have specific instructions. Then we're given this chart that has their names to see who married who. Our first clue is telling us that Kitty is married to Will. So we place a circle for Will because she is married to him. That's our first clue that's already given to us. So that makes David, Floyd, and Gus she can't be married to them because she's already married to Will, so we place an X. And we go ahead and place an X for Will for Sarah, Josie, and Annie because they cannot be married to the same person. In the next column to the right, Sarah has a brother, Floyd. Therefore, they can't be married, so you place an X on it. Josie and Gus are not married, so we put an X. They dated, but they're not married yet. They were never married. So you place an X. Josie is then married to David, and Annie has to be the only child, so it can't be Floyd because he has a sister. Last, Sarah and Annie can't be married to Gus, leaving Anne is married to Gus, so we place an O. So Anne is married to Gus, while Josie is married to David, and Sarah is married to Floyd, and Kitty's married to Will. It can get a little confusing, but it gives us specific details, and then you can narrow it down. Like, if Sarah's married to Floyd, then nobody else can be married to Floyd, so everybody else gets an X. So it kind of helps out to think about it that way. Here, if we see a pattern, we are asked to place the dot pattern of a trapezoidal number. If we see the pattern between the three lines, we can see the difference between 3 and 8, which is 5. Therefore, we add 5 more dots on the second dot figure. So it's just kind of like a building process. You start off with 3 and then you build up to the second figure. We add 5 to the bottom dot figure to get 15 from A and add 7 to the bottom like shown above. By knowing what each dot row we know the module 1 has in 3 columns, 2 rows, 4 columns, and 3 rows, and 5 columns. To make the rectangle, we have to have a 4x6 and it's containing 4 lines in each, and 4 columns of 6. So that's what it's a 4x6. So we have four lines going this way, and then we have 6 lines going across vertically. So we have 4 lines going horizontal and 6 lines going vertically, which gives us a total of 24, and that's how we would do that one. This one, we are asked to get the 9th trapezoidal number to find the 9th term. So we can see we plug 1, 2, 4 in, like number 1, and then we will solve. So for 1 plus 1 plus 1, we plug 1 for n and then add 2. So as you can see, so 1 times 1 plus 2 equals 1 times 3 equals 3. Our equation would look like this. So for 2, we would be 2 times 2 plus 2, and then we combine like terms, which given us 2 times 4, which is 8. And for the third one, we will do plug 3 in for n, and then add 2. So 3 times 3 plus 2, which is 3 times 5, we get 15. And that is the end of this. I hope you guys enjoyed this very much. Thank you for watching.